Hello everyone and welcome to part 5 of making a cloud game. I'm Sriram and by the end of the 4th video, we had the cloud backbone of the game completely ready, as well as the initial arrangement of the squares. In this video, you will have most of the game mechanics ready and you will actually be able to play against an opponent. The winning sequences and the game end screen we will do in part 6, but this is still massive progress compared to where we are at now. Before we proceed, I must mention here that in case you have not watched parts 1 to 4, then click on the card up here to watch them right now. Let us now begin programming the scripts. We first go into the square sprite and create a few variables. First we create moves made for all sprites, then winner for all sprites, then sending value for all sprites, and finally turn for all sprites. All these variables have pretty self-explanatory names. Moves made keeps track of the number of moves that both players have made. Winner keeps track of whether any player has won the game. Turn keeps track of which player has to move next. And the sending value variable will be used to transmit particular squares occupied by a player, but more on this later. We set moves made to 0 and winner to none. We set sending value to blank and finally turn to 1. Let us now move on next to a square click. When a square is clicked, we need to check a few conditions before we transmit a change in the square value. First, both the players must be online, so player 1 and player 2 must not be blank. Then we have to make sure that the object in question is a clone and not the sprite itself. Also, at this point, no one should have won the game. Finally, the square should be empty and the player attempting to click the square should only be allowed to do so if it is their turn. If all of these conditions are true, then we set sending value to the joint result of itself and square number. This line may be a bit confusing to you, but don't worry about it as you will understand why we do this later on. Next, we head over into the player sprite and within the send cloud data custom block, we encode sending value. This way, whatever square was clicked by the player will be stored in the respective cloud variable. Since we have set the necessary information to the cloud variable, we have to add some changes to the player reader sprite. We create a custom block for this sprite called update background, making sure to run without screen refresh. Then we create another custom block called check winner with the text input of side. Then we create another block called decide turn with the same setting. I will explain the purpose of each one of these blocks, but for the moment just follow my scripts. After the player variable is updated, we update the background. Then we check if moves made is under 9 and if it is, then check winner X. If after this the winner variable is none, then we check winner O. If the winner variable is still none and has not changed, then we decide the turn. Alright, let me now explain what each one of these blocks do. The update background function will ensure that the backdrop is blank when both the players have joined the game. We know that moves made will be storing the number of times both the players have played. When the moves made are less than 9, it means that there is at least one empty square on the board, and this condition eliminates the possibility of a stalemate where all the squares are occupied and neither player has won. Programming this case is slightly difficult, so we will leave that statement for part 6. The check winner function will check if the inputted player has won the game. If the player has won, then the winner variable will be set to that player. So if the winner variable stays as none, we check if the other player has won. If the winner variable still stays as none, then we ensure that the next player's turn is decided and only they can move next. By now, you probably have an overview of what each function does, so let us actually go ahead and program them. Let us start with the update background function. This is very simple. We check if both the players are present in the game, and if they are, then set backdrop to blank. This just ensures that the backdrop doesn't say waiting for opponent when the opponent has already joined the game. Okay, let us move on to the decideTurn function. We create a variable for all sprites called square counter. At the beginning, we set square counter to 1 and moves made to 0. Within a repeat 9, we check if item square number of square list is not blank. If the particular item is not blank, then it means that it is an X or it is an O. In either case, it means that a move was already made earlier, so we change moves made by 1. At the end of this loop, we will have the total number of moves made. If the number of moves made are even, then the turn should be player 1, and if the number of moves made is odd, then the turn should be for player 2. Great, now we have to program the check winner function, and in order to do this, we need to create a list first. So we go into the initializer sprite and first create a function called initGlobalVariables, making sure to run without screen refresh. Next, we create another custom block called setUpWinningSequences, making sure to run without screen refresh. When the green flag is clicked, we first initGlobalVariables and after the other two blocks, setUpWinningSequences. Within the initGlobalVariables function, we set player 1 and player 2 to blank, and we also show both of these variables. Now let us code the winning sequences list. We first create one called winning sequences for all sprites. We delete all of it at the start and then add every possible winning combination. What I mean is every possible way in which a player can win. So for example, the player could capture the squares 1, 2, 3 and win. Similarly, capturing the squares 4, 5, 6 would be a win, and so on. Let us add these numbers. We add 1, 2, 3, then we add 4, 5, 6, then we add 7, 8, 9. For the vertical column wins, we add 1, 4, 7, 2, 5, 8, and 3, 6, 9. For the diagonal victories, we add 1, 5, 9 and 3, 5, 7. This should make pretty good intuitive sense so far, and I will make just one small correction by changing 3, 5, 7 to 7, 5, 3. The reason I'm doing this will become clear in the next video, just ignore it for the moment. Great, we now have everything we need to program the check winner function. We first create a new variable called d for this sprite only. At the start, we set d to 1 and then throw in a repeat 8. The reason we repeat 8 times is because we will loop through the winning sequences list and that has 8 elements in it. Each time in the repeat, we check if item letter 1 of item d of winning sequences of the square list is equal to side. This may seem a bit daunting, but if we go through it, it should make sense. Letter 1 of the first item of winning sequences is 1. Now, to check if this particular winning sequence is on the board, we must make sure that square 1 is occupied by the player. We must also make sure that square number 2, which is the second letter of the first item in the winning sequences list, is occupied by the same player along with square number 3. In essence, within the square list, the items which are letters of an item in the winning sequences list must belong to the same player. So let us complete this condition. It must be true for letter 1, letter 2 and letter 3 all at the same time. If this is true, then we set winner to side, which is X or O depending on the input. We can also create another variable called winning index and set it to item D. This should be pretty self-explanatory. Since we are looping through the winning sequences list, each time we change D by 1. We have to keep in mind that at this point, we do not have a receiving mechanism. We send the squares that are clicked by the player, but we do not receive the squares that are clicked by the opponent. What we need to do now is get those squares that the opponent has chosen and update the square list accordingly. Within the update player variable, right after we set player to value, we get next value and then get next value once again. The reason we do it twice is because the first time we get the timer and only on the second time do we get the sending value of the opponent. At this point, we set D to 1 and within a repeat 9, replace item D of square list with a blank. Then we change D by 1. This clears everything that there is in the square list. Next, we do the same thing except that we repeat the length of value and replace letter D of value with X. At the end of this loop, we will have all of the X's made by player 1 positioned correctly and the rest of the square list would be empty. In order to get the O's also correctly placed, we must do the same thing for player 2. For this, we duplicate everything after set player and drop it at the identical place for player 2. We have to be careful here though. We wouldn't want to empty all the squares at the beginning because that will also delete the correctly placed X's. So we need to add a condition making sure that the item is not an X and only then clear it. Of course, in the second repeat, we would only want the replace letter to be O as we are receiving values from player 2 and not player 1. And that is pretty much it. If you test the program now by playing it on 2 tabs, then you should actually be able to play a full game. The game also stops when a player has won, making the only improvement we need to program an animation and an end screen. With that said, thanks for watching and I will see you in part 6.